Yeah, then like all the careers doesn't have that such as say she died.
Yeah.
With later
That's why.
That's why you like teens. Grow into your butterfly.
Extrema can only occur at one of three places. So on a lot of these problems, they're going to say, hey, find all the relative extrema. Well, you're going to want to go dig into these three different categories of numbers. Looking at the examples we just talked about, this absolute max occurs at a what? What's significant about this graph? What's okay? And the
zero.
What's what now?
Well, the f prime is 0.
Okay, yeah. The slope coming into a max is, say, positive, and the slope going away from the max is negative. Which means f prime going into a max is positive, f prime going away from the max is negative. What happens at the actual max? Is f prime positive or is it negative?
It's neither.
It's neither. It's what? It's 0. So at x values, where the derivative is 0. You're going to want to figure out any x values where the derivative is 0. If you're just given a function instead of being given a picture, picture is easy to find. Max, you know, it's not that tough. But if you're just given an equation and asked to find maxes and mins, probably the first thing you're going to want to do is set the x, or figure out where the derivative of that equation is 0. Use those x values. We're going to test that. What if instead of being a nice, smooth, rounded off curve, we had a max at the top of a sharp turn? Okay, so the derivative would be undefined. So potentially, you'd want to check x values where the derivative is undefined. Finding x values where the derivative is undefined will find you maxes or mins on sharp turns, like the bottom of an absolute value graph. It's not defined, the derivative is not defined at the bottom of that v, but that is still a min. So if you set the, oh, I'm going to set the derivative equal to 0. Oh wait, the derivative never equals 0, but it's undefined. Well, that's why step 2 is in here. Account for those undefined values, the derivative. That, you cool with that? And then I guess, like, looking back at our examples, the third and final case, we really didn't have a perfect example, but if this dot had been filled in on the second graph here, if this dot had been filled in, what would we have right there? An absolute max at the endpoint. So endpoints are also something you need to check. The x values for endpoints are potentially x values of maxes and mins. These three types of x values, they're all candidates for maxes or mins. It's not a guarantee that any one of these will even give you a max or min, but they're the candidates. So if you ever have a problem that says, hey, where are the maxes and mins on this equation, or the graph of this equation, you would want to check these three things and then test them. You wouldn't just say, okay, all these things are, well, they might be. If three people have their name in a political race, they're just candidates. They're not necessarily going to win. Well, these three things are all vying for the title of absolute max or absolute min. It doesn't mean any of them are going to win.
Is one of them gonna
Maybe.
Probably, but not definitely.
Well, more than one of them.
Yeah,
I think number one is Barack.
All right, these three types of numbers are what we call candidates. There's a math word for it. We call them critical numbers. The x values that come from these three categories are called critical numbers.
It's tricky. There's so much sticky on this. It's kind of irritating.
That's knowledge juice.
That sounds like it.
That doesn't sound.
So much had exploded
I was
today.
thinking relax.
Their mind was blown.
That's how you should
Set
Oh my gosh, Skylar.
set an ice cube on a plate the other day at dinner, and it started melting, and my daughter looked at it and asked me if that was ice juice. She's 14, you think she'd know better.
Why'd you put an ice cube on the plate by chance?
I was trying to cool off the soup.
On a plate.
Yeah.
The soup cooling off the soup, so I removed the ice cube from the soup so as not to go too far in the other direction of temperature.
That makes sense.
That's what
That's what I was.
I had it all mapped
That's
out.
what I figured.
I'm glad that's hilarious. I'm not sure why.
See, said black man, black man.
All right, so in the next couple examples, you'll be given a function over an interval. You're going to want to find all the relative and absolute extremes.
It's just right at home with like thermometer, like washing the ice cube. Oh, it just like takes it out of the direct temperature.
I feel like that's a little bit
How's that mean? It's just I can see it. I can see snow.
We got f of x is negative 2, or I'm sorry, f of x is x squared minus 2x on 1 is less than or equal to x is less than 3. So we've got a function and we've got an interval. What do you suppose? That's great.
That's probably
What do you suppose we're going to have to do?
Find the derivative of fx.
Okay, we're going to find f prime. Yep. F prime of x. That's 2x minus 2.
So,
The derivative is going to equal 0 when x equals, what is it?
1.
1. Right? 2x minus 2 equals 0 and x is 1. Where is f prime undefined?
3.
Keeping in mind it doesn't have to ever be undefined.
It's not.
It's never undefined. This is just a line, right?
Yeah.
It's always going to be defined. Every x value has an actual resulting y value. So far, how many critical numbers have we found?
Uno.
1. How many more things do we have to check?
One more.
One more category of endpoint, or
Endpoints.
critical numbers. We have to look at the endpoints.
right under now.
The endpoints are 1 and 3. Endpoints are 1 and 3. So to figure figure out if we're dealing with maxes or mins or what, let's plug these critical numbers into the actual function. Am I going to plug them into f or f prime?
Prime.
If you want to plug them into f. If you plug them into f prime, you're gonna, you know what you're going to get if you plug 1 into f prime? You're going to get the slope. You're going to get 0 back, which is how you got the critical number in the first place. So you want to actually go back and plug them into f. That will give you y values. Y values tell if you're way up high or way down low. So you want to plug the critical numbers back into the original function and see what your highest y value is, what your lowest y value is, and maybe anything in between. F of 1. What's that give us? Yeah. -1. And that actually is included. The thing is, I don't know if that's a max or a min. So what I'm going to do is I'm going to go ahead and plug in f of 3. Even though 3 is not included, it's going to at least tell me if the graph is trending up or trending down, you know? If it's trending up, this will be a what? If it's trending up, this will be a min. If it's trending down, this will be a max. So f of 3, 9 minus 6 is 3. But, now that's not included in the actual graph, so I can't say that 3 is my max because that endpoint is not actually included. If I had a -1 is less than equal to x is less than equal to 3, I'd say, yeah, that's my max. 3 is my max. Since it's not included, I'd say there's no absolute max because that high point's not truly included.
How do you know -1 is included?
Because they give you the less than or equal to sign. Because of that.
Equal to 1.
Yeah.
And then you plug in.
So this, if you were going to graph this interval, you'd have the 1 would be included, it'd be a dot because of this equal to part of the symbol.
Oh.
This would be a circle.
Because you used 1 as the number and it's -1 is a y.
Yeah.
Oh, okay, so it's just a coincidence.
Yeah. -1 is the absolute min. There wouldn't be any relative extrema because apparently, even though this is a parabola, it's not, well, really parabolas aren't going to have any relative extrema, are they? They're just going to have an absolute something.
Absolutely. Or max.
Or
Got room in your heart for one more?
Oh, Ruben.
Told you it's
Superb in mind.
Yeah, you were.
I don't want to see you.
Maybe I'll